This video is going to cover the topic of linear relationships. Be sure the date and topic are at the top of your page. The essential question for this video is, what is a linear relationship and how do we recognize it? We have been working with algebraic relationships. We have seen the connection between two variables such as time and distance. This connection can also be called a relationship. Sometimes that relationship is predictable. In a predictable relationship, when one variable increases or decreases, you know exactly what will happen to the other. For example, perhaps you earn $8 an hour babysitting. That means for every hour you work, you earn $8. That's predictable. This is also known as a linear relationship. We can see linear relationships in both graphs and tables. Let's start by looking at tables. This table will show the number of chaperones required for the number of students who are attending a field trip. This table shows a linear relationship. I can see that for every 9 students, they require 1 chaperone. Right? And I can tell that because every time this increases by 1, the number of students increases by 9. So they're staying constant. It's consistently the same pattern for both of our values, both of our variables. Let's take a moment to look at a second example. This table will show us the variables of seconds, time in seconds, and the number of jumping jacks that someone has completed. If we take a look at this table, we can see that the number of seconds is increasing consistently by 10 seconds per interval. Right? But what's different here is that the number of jumps is not predictable. So we went up by 15 here. Here we only went up by 10. Here we went up by 12. Here we went up by 9, right? It's not predictable. We can't predict the number of jumps that someone would do in 60 seconds, right? We can make an educated guess, but we wouldn't know for sure. This is not a linear relationship. For this to be a linear relationship in a table, the values for both variables should be growing at a consistent rate. We saw that with our chaperones, but not with our jumping jacks. Linear relationships are especially easy to see in graphs. The name linear probably gives it away. In a graph, we can see a linear relationship if it makes a straight line when we look at the data all together, right? The data would be connected with a straight line. In our first example, the number of students and the number of chaperones, the number of chaperones depended on the number of students, and the graph of the data would look like this. Now, I can't really connect these points, right, because I can't have a continuous number of students or chaperones, right? I can't have fractions of amounts there. But if I could, right, and I'll do it with this slightly dotted line here, the line that I would make would be a nice straight line. That straight line tells me very visually that this is a linear relationship. In our second example, the number of jumps that we completed depended on the amount of time that passed, right? So my data looks like this. And again, I'm going to show the connection here with a dotted line, but you might notice this time the line is not one straight line. Right? That's the difference. This is non-linear. And it might look that it's only slightly off being a perfectly straight line, but it doesn't matter, right? If it's not a straight line, it is not a linear relationship. The essential question of this video was, what is a linear relationship and how do we recognize it? We've seen that a linear relationship is a predictable connection between two variables, and we've seen that we can see it both in tables and in graphs.